Jupiter. Jupiter is the fifth planet from the Sun and the largest in the solar system. It is a gas giant with a mass more than 2.5 times that of all the other planets in the solar system combined, but slightly less than 1,000th the mass of the Sun. Jupiter is the third brightest natural object in the Earth's night sky after the Moon and Venus, and it has been observed since prehistoric times. It was named after the Roman god Jupiter, the king of the gods. Jupiter is primarily composed of hydrogen, but helium constitutes 1/4 of its mass and 1/10 of its volume. It probably has a rocky core of heavier elements, but, like the other giant planets in the solar system, it lacks a well-defined solid surface. The ongoing contraction of Jupiter's interior generates more heat than it receives from the Sun. Because of its rapid rotation, the planet's shape is an oblate spheroid. It has a slight but noticeable bulge around the equator. The outer atmosphere is divided into a series of latitudinal bands, with turbulence and storms along their interacting boundaries. A prominent result of this is the Great Red Spot, a giant storm which has been observed since at least 1831. Jupiter is surrounded by a faint planetary ring system and a powerful magnetosphere. Jupiter's magnetic tail is nearly 800 million km, 5.3 astronomical units, 500 million mile, long, covering nearly the entire distance to Saturn's orbit. Jupiter has 80 known moons and possibly many more, including the 4 large moons discovered by Galileo Galilei in 1610, Io, Europa, Ganymede, and Callisto. Io and Europa are about the size of Earth's moon, Callisto is almost the size of the planet Mercury, and Ganymede is larger. Pioneer 10 was the first spacecraft to visit Jupiter, making its closest approach to the planet in December 1973. Jupiter has since been explored by multiple robotic spacecraft, beginning with the Pioneer and Voyager flyby missions from 1973 to 1979, and later with the Galileo orbiter in 1995. In 2007, the New Horizons visited Jupiter using its gravity to increase its speed, bending its trajectory en route to Pluto. The latest probe to visit the planet, Juno, entered orbit around Jupiter in July 2016. Future targets for exploration in the Jupiter system include the probable ice-covered liquid ocean of Europa. Jupiter is believed to be the oldest planet in the solar system. Current models of solar system formation suggest that Jupiter formed at or beyond the snow line, a distance from the early Sun where the temperature is sufficiently cold for volatiles such as water to condense into solids. The planet began as a large solid core, then accumulated its gaseous atmosphere. As a consequence, the core must have formed before the solar nebula was fully dispersed after 10 million years. Over about a million years, Jupiter's atmosphere gradually expanded until it had 20 times the mass of the Earth. The orbiting mass created a gap in the solar nebula, and thereafter the planet slowly increased to 50 Earth masses over 3 to 4 million years. According to the Grand Tack hypothesis, Jupiter began to form at a distance of roughly 3.5 astronomical units, 520 million km, 330 million mile, from the Sun. As the young planet accreted mass, interaction with the gas disk orbiting the Sun and orbital resonances with Saturn caused it to migrate inward. This upset the orbits of several super-Earths orbiting closer to the Sun, causing them to collide destructively. Saturn would later have begun to migrate inwards too, much faster than Jupiter, until the two planets became captured in a 3-to-2 mean motion resonance at approximately 1.5 astronomical units, 220 million km, 140 million mile, from the Sun. This changed the direction of migration, causing them to migrate away from the Sun and out of the inner system to their current locations. All of this happened over a period of 3 to 6 million years, with the final migration of Jupiter occurring over several 100,000 years. Jupiter's departure from the inner solar system eventually allowed the inner planets, including Earth, to form from the rubble. There are several problems with the Grand Tack hypothesis. The resulting formation timescales of terrestrial planets appear to be inconsistent with the measured elemental composition. It is likely that Jupiter would have settled into an orbit much closer to the Sun if it had migrated through the solar nebula. Some competing models of solar system formation predict the formation of Jupiter with orbital properties that are close to those of the present-day planet. Other models predict Jupiter forming at distances much farther out, such as 18 astronomical units, 2.7 billion km, 1.7 billion mile.